Probability describes the likelihood of a certain event occurring. So here we see the probability of A, and oops, this should have still been around A. The probability of A occurring and the probability of A not occurring is equal to 1. So the probability of A not occurring would have been the area out here, but it got messed up. So here we have two events, A and B, and again, the total probability is 1. The probability of A and B happening is denoted this way, probability of A and B. And if these two events are independent, if A and B are independent, then this probability is just the product of the two. For example, say we were assembling computers and we bought the PC from one vendor and the monitor from another vendor, and the PC had a likelihood of failing of 10%, so the probability of a defective PC was 10%, and the probability of a defective monitor, so that would be B, probability that a monitor would be defective would be 5%. Well, then the probability that our assembly, our PC and monitor assembly is defective is the probability of a defective PC times the probability of a defective monitor. So that would be 0.005, or 0.5%. And here we have the probability of A or B. You can see the probability of either one of these occurring. And this is equal to the sum of probability of A and probability of B minus the probability of both A and B happening. And if the two are mutually exclusive, then that term is 0. So if A happens means B cannot happen, then this term will be 0. Now we often want to use our sample data to predict population behavior. And typically the behavior is not identical. So typically our sample is not going to behave exactly like the population, meaning it won't have the same central tendency, it won't have the same dispersion. In a lot of situations, the population behavior follows a known mathematical function to a given degree. And what we use our sample data for is to compute the parameters of those functions. For discrete variables that can only have certain values, then these functions are probability mass functions. And for continuous variables, they're called probability density functions. Here's an example of a probability density function where we have somebody throwing a horseshoe at the target, which is xm away. And if we sampled their throws, then we would want to come up with this function here representing the probability density function. So the probability that their throw is a certain distance away. And there are different functions, and which function applies to a given situation is often known from experience. There's also a goodness of fit test that can assess the suitability of a probability function to a certain situation. We'll look at the goodness of fit tests later. Probability mass functions. Again, this is the probability function for a discrete variable. And it's given by this notation, probability that event xi will occur, or that we will have a value xi. The average value, or the expected value for this population, is called the mean. And since the sum of all the probabilities is 1, then the mean is given by this sum here. It's the weighted average of all the values. So the sum of all the values multiplied by the probability for each value. And the population variance is the dispersion for the population, and it's given by this equation.